So welcome at the last session of this day in this room, and Patrick will tell us something about signing of packages.
Hello, can you hear me? Or so, as some of you might know, I'm responsible for the way we currently sign our packages in Fedora, and since most people have no idea how that actually works, I figured I'd tell some of the backstory and how we actually implement signing. So first of all, I wanted to tell a bit about what problem we're trying to solve, and then how we are actually signing Fedora packages. So the main thing is the person introducing me said we are signing packages. We are not only signing packages, we're also signing things like checksum files and Docker container files that we ship. Pretty much all of the artifacts we ship, we try to sign so that people can verify that the bits they got are actually the bits that were produced by the Fedora infrastructure or by the Fedora projects in our infrastructure under controlled environments and have not been modified during the transition from us to their user. Part of the reason that's very important is because we heavily use a mirror network, and technically, since you only download things from a mirror, the mirrors could technically modify things, and there have been instances in other projects where that has happened. Which is not the intention of us, so we're doing our best to prevent any of that. So as a consequence, we want to sign the artifacts we're shipping. However, we do want to do so in a secure way, so in a way that not anyone who has access to our infrastructure can immediately sign any bits, because our infrastructure is reasonably open. But this part, we definitely do not want open. We only want verified bits to be signed. But it also should not be unusable. So that's always a balance between usability and security. I don't know if any of you have heard about, for example, the Freedom of Press Foundation. They actually have a system where for every release, they take a tarball on a USB stick to an air-gapped machine, sign it there, and then move it back to publish it on the internet. That's not really doable for Fedora because of the fact that we have a significant amount of packages and other artifacts we're shipping. In addition to the fact that we have Relinch, which is our release engineering team, we have some churn in there. So at various times, people leave, people get added. When they leave, they should no longer have access to their keys. But when they get added, we do want them to have access to the keys. So how do we manage that? We have a piece of software for that called Sigil. We've been using that for multiple years, I think 8 or 10, which is basically a solution based on 3 systems. You have the client, which is what the release engineering runs for, that submits the actual packages they're trying to sign. There's a bridge, which is in between, and there's the vault, which actually has the keys. The software component is called server. Our servers are called the vaults. That's just the naming. So one of the things we really wanted is that the vault has no inbound connections at all, ever. So how do you then still connect to it? The vault connects to the bridge, the client connects to the bridge, and the bridge multiplexes the connections between the bridge and the vault. As a consequence, as I said, the server has no inbound connections at all. The bridge has 2 inbound connections, which are very clearly defined. All of this uses industry standard TLS communications, so that it's not custom crypto or anything. It's using currently the NSS library, for those who are aware of that, which is the same TLS implementation that Firefox, for example, uses. As I said, Sigil actually supports multiple users. So for every key, you can have multiple users who each have their own key access to each. For every user, you can or cannot have access to a particular key. So for example, Fedora 26 or Fedora 27, that access can be revoked. And when a Relish person tries to sign something, they send the package they're trying to sign, including their key passphrase. That on the server, the key passphrase gets decrypts the actual key, the actual passphrase of the GPG key. It signs the package and sends it all the way back to release engineering or Koji, after which everything has been signed. However, so this did work for a number of years, but there have been some challenges. For example, for those who are aware, we have a distribution called Rawhide, or version distribution, which is literally just whatever people build with no updates gating, just moving along very quickly. In addition to that, the signing is a pretty involved process because so what Relish had to do was literally make Bodhi, our updates management system, get a list of all packages that are currently out for pushing, hold that list in memory, ask for Sigil, please sign everything that's currently in this list, wait until everything is signed, and only after that they could say to Bodhi, yes, continue pushing. This took a lot of human hours because sometimes it would crash. Other times, things that were supposed to be signed weren't, or more packages get submitted while that is ongoing. In addition, there were very few people who were actually, it was a very vague process, so the set of people who are able to access this system was very low. So that in combination with the fact that we wanted to sign Rawhide, which this process just doesn't scale to Rawhide because there's no set list at any point in time because it moves along very fast. As a solution, as of literally a bit over a year, we're now actually automatically signing all of the Fedora packages. Hopefully still in a secure way, because I tried not to break any of the security properties that we set out with. This is done with a tool called RoboSignatory. So if anyone sees that name around, that is our robot which does signing, and because I'm terrible at naming, I call it RoboSignatory. Most of its signing are based on that message. So when a package gets tagged into a particular Koji tag, so as soon as you go into Bodhi and you say, I want to submit this update for updates testing, the update is queued for signing. At that point, it gets signed by RoboSignatory, which then gets reported back to Bodhi for, okay, on the next push, you can just push this along and assume that it will be signed. We also sign RPMOS3 composes, which is which is composed during nightly runs or for updates, also during the same updates push. So it also catches those composes and signs those trees as well as soon as they come in. We also sign Docker containers. That's currently not that message automated yet because that needs some changes to our build pipeline, but that's also incoming. However, this does mean that an automated system actually has the keys or has the passphrase to sign Fedora packages. So how do you still protect it for when someone gets an entire dump of that system? What we did for that is that all of the keys that are used for this are so-called bound to the hardware, which means that they have cryptographical hardware. So either a trusted platform module or a YubiKey, which actually encrypts part of the key before storing it anywhere. So the automatic signer box does not actually have the full passphrase it needs to send. It has an encrypted version of it, which as long as you have the attached YubiKey, it can decrypt and then send onwards. And on the Vault side, we also have it bound so that after it gets decrypted with the user passphrase, it gets decrypted with the trusted platform module in those boxes. So if anyone ever gets the full data dump of those servers, there's nothing they can do with it because all of that data is fully encrypted with hardware that's literally under our control. So this approach is also layered, which means that on one of the ends, it can be encrypted with both a YubiKey and a TPM and multiple other layers at some point as well, so that you can actually per key say what trust level you want for that storage. So that's how we currently do auto-signing. There are some rough edges that we're currently still trying to fix. First of all, I'm reworking RoboSignatory so you actually get a web interface so that normal people can actually see where their package is in the signing process. So you can actually see the queue of all of the packages that are going to be signed and in what stage they are, because first it needs to gather some data, then it can sign it, and then upload the data back. Also, right now it's all a single stream, so it's literally a single queue with all of the packages going through in one go, which means that every package will need to wait for every previous signed package or other artifact. And I've been working on parallelizing that so that it can actually, while it's still downloading one package, it can already sign the next one because those things aren't depending on each other. At this point, it's also still possible that humans sign it. So there are still people with actual access to the signing keys. I really want to get rid of that. Not because I don't like humans, but because I don't think they are very good at keeping things always secure. And right now, we still need to manually synchronize the data between different single vaults. We have two of them with one active, one passive standby for if the first one crashes. Right now, that's still manually synchronized. The idea is that that all happens automatically, and that literally the only thing you need to do is flip the switch and you can fall over to the passive one. Those are the plans I'm still working on. Are there any questions? Yeah.
First, congratulations for a very particular with a hot-seat approach. I was like a few years ago. Certainly we need something more simple starting package. But I have a question. Why you don't store the keys in hardware instead of using hardware-bound approach?
Part of that is because at least at the time that all of this was, sorry. The question was why we actually go to the fact of binding the keys to the hardware rather than storing the keys directly in a TPM or a hardware token. Part of that is because of the fact that at least at the time that Sigil started, there was literally there was no open source HSM that could actually handle things like GPG. So at that time, there just wasn't an alternative, and right now it's more a, I think there are some alternatives maybe, but we've kind of bought into this now because the key is encrypted, and yeah. Also, depending on what HSM you'd use, synchronizing between multiple devices becomes really hard if the key is generated on HSM. Right. So we are looking at moving to HSMs. We're evaluating some, but that hasn't happened before now. Any other questions? Oh.
Email the private key.
No. The question was, will I email the private key? No, I do not even have access to the private key. Like, I couldn't even if I wanted to. Right. So the question was whether the new web UI I'm working on will help with getting signed copies of packages from Koji, because right now that's kind of hard to get. You can get them right now. It needs some manual tinkering to find the URL for it. The web interface is not meant for that, but that's actually a good idea. I might just add that to it. I just never thought about that. If you're in the know of things, then it becomes hard to remember how it was before you knew.
So you're transferring all the RPM over to the time as a whole file?
Yes, right. The question was whether we're transferring the entire file, the entire RPM we're signing over the network. Yes, the bridge part downloads the entire RPM from Koji, sends it onto the server, which sends the entire RPM back, and then it sends the signature onto Koji. That's the current implementation, yes.
Would there be interest to only send the checksums over to the time?
The question is whether it would be interesting to only send the checksums back, and yes, I do have a to-do item to, at least for the return path, so after it's signed, no longer return the full RPM, but only the signature. For the way there, we had a ticket for that. It's mainly the fact that Sigil actually, on default, checks all of the contents of the RPM for safekeeping of the log entries. So we actually have a full log on the server of exactly what was signed. And if you send just the checksum, you'd have to trust the information that the client and bridge are sending, which we try not to do. So what's being said is that you have to trust the bridge to send the right package. Not exactly, because, well, yes and no, but the main thing is, at this moment, we have a log entry of this was the exact NVR, and this was the checksum we signed. Right now, we know that we can look that up in Koji. sorry. I'm trying to think because we have a ticket where we have reasoning outlined. I can send it to you. I'm just blanking out at this time, sorry.
Wouldn't be our goal unique, so once an NVR is signed, we could have someone like do another sign.
The question is about uniqueness, and Sigil does not enforce any kind of uniqueness.
Could you? Well, just kind of thinking about this.
Maybe, I don't know right now. Please ask me again later. If there's no further questions, then thank you for listening.